Hello everyone, this is Muhammad Ilyas Azim, PhD student at Institute of Software, University of Chinese Academy of Sciences. Today I'm going to present my paper, Action-Based Recommendation and Pull Request Development. So let's start it. Popular open source projects on GitHub receive many pull requests every day. Tens, even hundreds of pull requests every day, making it difficult for the integrator to select the most likely to be accepted or responded to pull requests. The job of the integrator is not easy. On the one hand, he has to ensure the quality of the submitted pull requests. On the other hand, he has to make a communication with the contributors to discuss the submitted pull requests. Communication plays an important role in pull-based development, as contributor is the key to the success of open source projects. Normally, integrators perform this selection process manually, which make it more difficult and need more effort and time. This process becomes much more difficult when integrators have large workload and limited resources. To cope with this problem, we came up with a solution called Cartesian acceptance and response classification-based request identification. Cartesian is a multi-class classification recommendation system, different than the previous works, which are either based on acceptance of the pull request or response of the pull request to prioritize the given set of pull requests to the integrator. Cartesian recommends three actions which is to be taken by the integrator, either to accept the pull request or respond to a given pull request or reject the pull request if it has low quality. To implement Cartesian, we followed two steps, the feature extraction process and then training of the classification model. Features were extracted from 19 popular GitHub projects, and the extracted features were divided into these four dimensions: the pull request itself, the project, the contributors, and the integrators. These are some of the examples of the features extracted from these categories. In total, we have extracted 68 features from the pull requests. Cartesian models the PR recommendation as a multi-class problem. Now, these three actions which is to be taken by the integrators contain those pull requests, except contains those pull requests which are directly accepted by the integrator without any discussion with the contributor. Respond contains those pull requests which are also accepted but after making a discussion with the contributors. And reject contains those pull requests which are either directly rejected or rejected after discussion with the contributors. We crawled data from 19 popular GitHub projects belonging to different domains and programming languages in order to make this model more generalized. And pull requests were extracted since the projects are created until February 2018. We have used GitHub REST API version 3. The extracted projects are shown here in the table along with their statistics. The distribution of the dataset shows that this dataset is an imbalanced dataset. In experiment 1, we have trained 7 different classifiers in order to identify which classifier can betterly classify the pull request into the 3 categories. The aim was to identify the best performing classifier as the ultimate classifier for a Cartesian. During experiment 1, we performed some feature selection process, and the traditional evaluation metrics: accuracy, recall, precision, and F measure were used for the evaluation. In experiment 2, we wanted to evaluate the performance of the Cartesian, and we compared it with the baseline model. Previous studies shows that integrator give priority to those pull requests which are small in size, and they serve the pull request in first in, first out manner. Secondly, we performed a qualitative analysis in order to identify how useful these pull requests are for the integrators. And during experiment 2, we use mean average precision and average recall as the evaluation metrics. Experiment 1 results shows that XGBoost has outperformed the rest of the classifiers in all the evaluation metrics. We have used XGBoost as the ultimate classifier for Cartesian. Average accuracy, recall, and precision achieved by Cartesian is 86%. Feature importance analysis shows that the classification is mostly impacted by the number of review and discussion commits, the role of the submitter, and the participant who took part in the discussion. Overall, the classification accuracy is driven by the contributor and integrator dimension. Results of RQ2 shows that Cartesian has outperformed the baseline models in prioritizing the statistically significant amount of pull requests. We have selected 380 pull requests, which are divided into 10 samples. Each sample contains 38 pull requests. Previous studies shows that integrators give priorities to those pull requests which either fixes bugs or add new features to the project. The pull requests recommended by Cartesian are analyzed qualitatively, and we find out that 24% of them are bug fixes, 17% of them are new features, etc., which shows that Cartesian could be a good support to the integrator to recommend them useful pull requests. In conclusion, we have introduced an automated tool called Cartesian, which can help the integrator in popular GitHub projects to select the most likely to be accepted or responded to pull requests. Cartesian shows a good performance, achieving average precision and recall of 86%. Besides, the qualitative analysis shows that Cartesian can recommend useful pull requests on the top of the list to the integrators. In the future, we are planning to integrate Cartesian to GitHub and evaluate its usefulness. We are interested to discover some more features, maybe quality metrics, to improve the performance of the Cartesian. Thank you so much for your attention. Goodbye.